right, so now we're heading into PoSSUM presentations. Bailey, would you like to introduce the first PoSSUM presenter?
Yeah, of course. And hi, everyone. I'm Bailey. I got to briefly introduce myself earlier. A little bit more. I'm from PoSSUM 1902, so I'm still pretty new to the PoSSUM world, and I very much enjoyed this aspect of getting to know, well, specifically, I worked with the previous team, and I think I worked closely with them, and they did a great job, and listening to everyone else's presentations has been amazing. You guys put a lot into what's going on here, so it's really been fun to watch that, and I'm really excited for you guys for your future. So the first one, and actually, Idil, you're gonna have to correct me here. I believe Kim's up next, right?
Correct.
Kim? Okay, awesome. Well, Kim, I'm really excited to hear from you. So Kim's going to be one of our PoSSUM, women in PoSSUM that can help give you ladies, growing ladies in high school. We're here to give you guys some tips on how to make what you just did even better and really just kind of polish it a little bit. So hopefully you guys can take these tips and anyone else watching and be ready for the next time even better. So Kim is first going to talk to us about designing a microgravity experiment. So now that we've done all these, what's next? If you guys want to design again, let's look into that, of a great way to design that. So Kim, go ahead.
Oh, hi, Adil. Don't worry about my slides. I think everyone's had enough of PowerPoint this evening, so I'm just going to chat. I think that, can you all hear me just fine? Yep, great. I'm from Australia. You might be able to tell that from my very slight accent. I know it's only just slight. Barely detectable, and that's fantastic. So I'm from the PoSSUM class 2001, and that's the class that hasn't completed their training yet. We're about halfway through. We were scheduled to do our PoSSUM class, and then COVID came by, and we haven't been able to do that, but hopefully my class will be able to fly in April next year. The rest of the time, I physically live in the US right now, but I work for an Australian university, and I am the convener for the Space Technology co-major within the Bachelor of Science and Engineering. And as well as that, we have a microgravity student program that sends an experiment to the International Space Station every year, and we partner high school students with our postgraduate students at the university, and they design an experiment every year. And I'd really like to say, being exposed to the program that we have, you should all be really proud of your accomplishments. I watched all of your presentations, both in the rehearsal and tonight, and you've all done an amazing job putting your research together. And I don't doubt that this will be the first experiment of many that you guys are going to do into the future. So let me just go through real quick. In terms of design, one of the most important aspects to design of a microgravity experiment is removing the risk of sending something which is expensive, because it's expensive to send an experiment to the International Space Station. So all of the techniques that you're learning and you're practicing here, using a drop tower, using parabolic flight, you can send an experiment on a sounding rocket. They're all about removing the risk of performing an experiment in space that's not going to work. So every step that you've undertaken and all of the important parts that you've gone through, they are really about removing risk. It was fabulous, that last presentation where you dropped your experiment to test it. That really shows exactly how you design an experiment. You test and test and test again. So I know that if everything functions the way you hope it will, and we know through all of our experiments that we've done and sent to the space station, not a single one of them actually functioned the way they should have on the station. They were all different experiments. One was to grow chia seeds on orbit. And the experiments that we send, they go to something called the Express Rack, which is a large rack on the International Space Station. It holds a large number of kind of cube experiments, which are about that big, a little smaller than the experiments that you guys made up. And what happens is you have a little board in there as well, and you program whatever you need to program in the same way as some of you guys did. And then that experiment goes inside the module, and it's sealed, and it's sent from Australia to the US, and then to the International Space Station, generally aboard a Cygnus rocket rather than those SpaceX rockets you've seen. And it gets plugged in. That rack on the International Space Station has a plug, and it's basically a plug and play experiment. And so that last experiment that went up, the chia seeds were meant to go up. There was water that would be pumped once the unit was under power, and that happened just fine. The water pumped in there. But the thing they didn't expect to happen was that the temperature of the Express Rack was 50 degrees Celsius. And of course, the seeds didn't germinate because it was too hot. So I think, you know, brainstorming and trying to work out with your design, what can go wrong? What are the different steps that I can take to kind of knock off all those things that can go wrong? And then, of course, one of the biggest things that I think you guys would have found really challenging was in the brainstorming part. I know that our students and our postgraduates really struggle with this. Is there are so many problems that they think of that they want to solve. How do you narrow it down to just one problem to address? Because you've got to start somewhere, and somehow you've got to make the decision about what's the most important challenge to address first. And so I think you all did a fantastic job of that. In your experiments, you really did say, okay, well, this is something we can do now. And that last presentation, you know, looking at the experiment for what can we do in the future and how can we test it further. So I think you guys have done a really great job. I'm here to answer questions anytime. I will put my email in the chat. Is it the questions or the chat that all the participants can see?
Right now, if you put it at the chat, the panelists and the attendees will be able to read it and contact you.
Excellent. So yeah.
Yeah, also there will be an email being sent out, unless it was already sent out, that all the presenters, the PoSSUM presenters, will have a fireside chat. Depending on interest, a schedule will be sent out.
No worries. So I think, you know, you've all done a great job. I think that all of you could really tell me a whole bunch of stuff that you really found to be the most important aspect to the design. And I know that all of you will be fantastic experimenters into the future. I swear, this is not going to be your only experiment. I bet every single one of you is going to be doing these experiments forever and ever after. And I'll be happy to be one of the people here to help you design experiments. Let's send stuff and get stuff into microgravity and really, you know, get out there. Awesome. You guys have done a great job. I'm so honored to have met you all. So I'll hand back over to Adel. I think we got some of the stuff is not quite in the right order. So you got to hear, I think you got to hear my section before another section, but.
No, we are fine. Star, would you like to introduce Shayla's video?
Cool.